infinite limits from section 3.5. But it's really similar to what we did already, and some of the top no, bottom O equal co, that still applies. Still applies. But be careful. You'll see what I mean by that in a minute. I mean, I guess you should always be careful in math class, but there's some extra tricky things on this one. And that's really it for notes. We're going to try some examples, but there's no new concepts to cover. We'll just work some examples together. Like a bunch of examples, but they'll go quick. Limit as x approaches infinity. And all of ours today are either infinity or negative infinity. So that means the top no, bottom O equal co stuff applies. So limit as x approaches infinity, 5x squared plus 3 over 2x minus 1. And again, you have two options. You can either substitute infinity and be careful doing that, or you can remember the little saying. I'll substitute first, because if you forget the saying, substitution still works. I get infinity over infinity, but x squared is a bigger infinity than just 2x, right? X squared is going to get bigger faster than x. So the top is getting bigger than the bottom, so there's not going to be a limit here. This is going to go to infinity, which means the limit doesn't exist. If you're just thinking shortcut, then right away the top degree is bigger, so it's a top no problem. So we've seen that one before. (3x) or limit as x approaches infinity, 3x minus 2x squared over 5x squared plus 1. So one of you, what's the answer to that one? The coefficient. That's the equal co. Again, you can think about it, x squared, those would be the most important factors of the top and the bottom. And so the x squareds would sort of cancel, or at least they'd be the only ones that mattered, and then your ratio would be negative 2/5. So that's the equal co example. You can guess what the next one's going to be. Limit as x approaches infinity of 3x squared plus 2 over 5x cubed plus, that's just a squiggly line because it doesn't really matter what comes after that. What's this limit going to be? 0. This is the bottom O example. That's the shortcut way. The long way is to think, well, if I plug in infinity cubed is a lot bigger than infinity squared. Like, they're both super big, but cubing it gets it bigger faster than squaring it does. So the bottom's getting a lot bigger, so it's headed to 0. Those are the three we already know. Now we'll have to be a little more careful with the rest of these. Limit as x approaches infinity of 5x plus 2 over square root of 9x squared minus 1. Yes, thank you. The board is messed up. Okay, so this is not, at least initially looking, it's not clearly top no, bottom O equal co, or it's misleading if you do try that, because you think the bottom is x squared, but it's not really x squared, because it's the square root of 9x squared. So let's look at the highest power of the top. Definitely 5x. The plus 2 doesn't really matter so much anymore. In the bottom, the minus 1, I mean, it's important, but when you're plugging in 5 million and then squaring it and multiplying it by 9, I mean, how important is it really? So this is all approximate now. But when x gets really big, it still works. So it's 5/3. It's sort of an equal co problem, but not really. But kinda. So with the square roots and squareds, you just have to be careful in there. All right, you try this one. Very similar problem. Negative square root of 2x squared plus 3 all over x minus 1. So I'll give you a minute to try that one. Really similar to that last one. Answer is not quite as nice though. Yeah, I feel bad marking out the 2 and the 1 because that looks like they cancel, and those don't cancel. So they don't matter when x is really big, but they don't cancel. So I don't know that I should have done that. It's a little bit misleading. But if I put the squiggles, I think that's fair. That means approximately it's equal to this. When x gets really, really big, the 3 doesn't matter, the 1 doesn't matter. Everybody got that far, and now it's like, oh, how do I do the 2 and the x squared? Well, just separate them if it's bugging you. And then now those can cancel, the square root of x squared and the x. And so we get negative square root of 2. So again, it's equal co, kind of. Just, careful. Let's see. Well, all of those are easy. Let's do one that's a little bit harder here. Limit as x approaches negative infinity. 3x squared minus 1 over x plus 1. Okay, nothing weird on this one. This is the top no. I mean, that's not our answer, but that's the case it is. Top no, which means does not exist. But we want to be specific. It doesn't exist, but why doesn't it exist? And the question is it going to positive infinity or negative infinity? That's the only thing I'm worried about. The top clearly gets bigger than the bottom. So that feels terrible writing that too, because you can't really square infinity. You can't really substitute in infinity. But it helps us figure out the top is getting big, really big, but positive. The bottom's getting big, but not as big and negative. So really big positive divided by big negative would be negative infinity. So the answer is sort of both pieces. It doesn't exist because it goes to negative infinity. Does that make sense? And we're doing kind of fuzzy math here. Really big positive divided by big negative. So we don't know exactly what the numbers are, but the top's getting bigger faster. So it's heading to infinity, but the sign is negative. Last example. Limit as x approaches negative infinity. So it's when the negatives are in there, you got to be extra careful. Well, I guess you got to be careful with positive infinity as well, because you could have a minus x squared in there. In fact, I'm going to do one more example after this one. Limit as x goes to negative infinity of 2x cubed minus 1 over x plus 1. Well, it's clearly a top no situation, but is it going to positive infinity or negative infinity? And you don't have to write top no. That's part of the official answer. There's nothing wrong with writing it. It helps you understand what you're doing and helps explain to me what you're doing. That's fine. But if you just look at it and come up with the answer, that's okay too. So rethink the problem, then give away what the answer is going. So yes, but yeah. I'm waiting for you to finish your answer. So it's the top's bigger than the bottom. So the top's getting way bigger, way faster than the bottom. So it's definitely a top no problem. It doesn't exist. But we want to be more specific. Does it not exist negative or does it not exist positive? So 2 times negative cubed over negative. Again, the minus 1 plus 1 doesn't really matter. Negative over negative is positive, and I already know it's infinity. So D and E because it goes to positive infinity. Okay, legitimately last example this time. Limit as x goes to infinity of 3 minus x squared over x plus 4. If I go to plug in infinity, I mean I can't really plug in infinity, but kind of. 3 minus infinity squared over infinity plus 4. Well, I don't care about the 3 and the 4 so much. So I'm getting negative really big. Or maybe I should have backed up and said top no, does not exist, because it goes to infinity, and now I'm just worried about is it positive or negative. So in the top, I've got a negative sign. In the bottom, it's going to end up being positive. So that one is negative infinity. So be careful with the signs. So the top no, bottom O equal co stuff still works, but be careful with the signs. All right, the assignment is page 202. 19 to 31 odd. So that's different than what's on the calendar says all, but I'm changing it to odd. So 202, 19 through 31, odd, not all.